Najwa binti Muslim, and I will explain to you guys about the theory of this topic, which is the friction of an inclined plane. When a block is placed on an incline, the tendency is for the block to slide down the plane. If the angle of inclination is small, the block is prevented from slipping by the friction between the surfaces. As the angle is increased, the force exerted down the plane due to the weight of the block also increases. However, the force pressing the surface together will be decreased. At the angle of friction, the force acting down the plane just to overcome the friction and sliding will take place. This could be described as in the figure. The sum of forces that parallel to the inclined plane is the total of force equal to 0. From the first equation, P is equal to S plus F, we could get the final equation, which is P equal to W sin theta plus mu W cos theta, where P is the force that required to overcome the friction to pull a block up the plane. S is the force acting down the plane due to the weight, while R is the force pressing down the surfaces together causing friction, and F is the friction force. Next, the coefficient of friction can be obtained from the equation if W sin theta is equal to mu W cos theta. Hence, mu is equal to sin theta over cos theta, which is equal to tangent theta. Theta is the angle of inclination of plane, and mu is the coefficient of friction. That's all from me. Thank you.
Hello, Assalamualaikum. Today I want to explain about the conclusion of the friction of the inclined plane. For the conclusion, in the inclined plane, let the relationship between normal force and frictional force between wood and steel was determined, as well as how to use a surface at multiple angles and force need to move an object on the surface to determine the frictional coefficient between two objects. Using the surface angle and the block mass, we can calculate a relationship between normal force and frictional force. Once that relationship determined, it can be used to calculate the frictional coefficient of the two surfaces. This can be used to predict the interaction between objects made out of this material. There were several sources of error in this lab. This include the need to place a folder underneath the incline in order to level it, the lack of consistency with the block movement due to its uneven surface, and the placement of washer and string onto the pulley in order to hang the mesh without the recording and additional mesh of dust item. Okay, that's all from me. Thank you.
Hi, my name is Nirvash Bharathan. I'm going to explain about the discussion of the experiment of friction on the inclined plane. The values of P obtained by the experiment are not accurately identical to the values of the calculation. The values of P from the experiment are not the same with the values of P from the calculation, which is caused by various reasons. First of all, the apparatus used are not in an excellent condition. The plane was used multiple times and caused a smoother surface compared to the condition when it was used for the first time. Moreover, lack of experience in conducting the experiment also contributes significantly to this error, specifically the failure to comply with the required consistency and accuracy to set the inclination angle on the plane. There are always at least two forces acting upon any object that is positioned on an inclined plane, which is the force of gravity and also the normal force. Objects are known to accelerate down inclined planes because of an unbalanced force at certain angles of inclination. Therefore, it could be mentioned that the friction of the inclined plane is influenced by the values of inclination angle, as well as the force of gravity, which is the mass of object. In other words, the friction force on an inclined plane can be defined as a function of the angles of inclination and the force of gravity. On the other hand, these factors give no effects to the friction on the horizontal plane, and it is mainly influenced by the external force acting on the body. From this formula, we can see the relation between the angle of friction and the coefficient of the friction, where theta is the angle of inclination plane and mu is the coefficient of friction. There are many engineering applications that showing the significance of the friction on the inclined plane. For example, traveling down a road with bald tires can be dangerous because there is less friction. Rain also can make the same road become dangerous, and if the driver drives faster, the contact between tire and the road can be lessened. Next, a screw is inclined plane that wrap around an axle. The friction of the screw makes it an excellent simple machine to join with two pieces.
Hi, my name is RUSYAIDI bin Muhammad RAIS, and I am going to explain the question of the topic friction on an inclined plane. Based on the experiment that we have conducted, we found that the greater the angle of friction, the greater the coefficient of friction. The engineering applications showing the significance of the friction on the inclined plane are: first, the significance of the friction on the inclined plane can be seen on the tire of a vehicle which have groove that increases the grip and resulting in greater friction, which are generated onto the road when going uphill or downhill to prevent from sliding and causing an accident. And the second example of engineering application can be seen on the surface of a slide at the playground, which were designed to be smooth so that when people are using it, they will be able to slide down easily. So that is all from me about the question of the topic.